Okay. So today is an interesting topic. Okay. So today we will learn about how do you do. Now, this is where things get interesting, right? Uh, so basically, until now, we have seen what exactly is Python as a programming language. How do we code in Python? What are functions? What are classes? What are different aspects of object-oriented programming language? How do you define functions? How do you write programs? How do you control the programs with using if-else? How do you write loops? And we have seen also like some applications like inbuilt applications like file handling, regular expressions, and we've seen a lot of stuff, right? But this is where things get interesting, where we actually dwell into the real world use cases. Now, how many of you guys have used Excel for doing anything with respect to your, like for doing some analysis, data entry, or uh, basically like trying to understand the data, trying to get insights from the data, right? How many of you guys have used Excel for doing that? I believe almost everyone, whoever is working, or even students, are supposed to know Excel, are supposed to, work with a Microsoft Excel, right? So, but if you guys understand about Excel, like the Excel formulas and all, one of the main limitations of Excel is it can't handle large amounts of data. Suppose if you have data in millions, okay, and if you want to do some automation, then it becomes very tricky, or sometimes it's not even possible. Although the starting point for anyone to do data analysis would be using Excel itself. But if you know Python, then things become a lot way easier if you know Python, okay? So the first thing which we will do, okay, is to basically, okay, let me actually get some okay, just a minute. Actually, let me get some data set from which we can work on, right? Which we can work upon. So paste, does this work? No, it doesn't work. Just a minute. Hmm. In fact, what you guys can do is download empty cars to dataset. Okay, so I am copy pasting this URL. Okay, I hope you guys have turned up your Jupyter notebooks already. What we need to do here is, okay, what do we exactly need to do here is go to this URL. I will copy paste, and this is a URL which has a CSV file associated with it. As you could see, emptycars.csv. Okay. So now, I mean, there are two ways how you can basically get this data set. One of the way, the automated way which you can do is basically say use okay, since you guys wouldn't be on Windows, let us do something like this. Go to this URL, okay, the URL which I have pasted, copy paste the entire thing, the content of the URL, okay. Go here, create a new file, okay, create a new file, and you should say here text file, okay. Here we are now making a text file, okay. Copy paste this, the content of it, and say Control S. Now go here and say rename, say empty cars, okay, and remove this dot text and say CSV, okay. So if you want, I can like add this as well for your convenience. But yeah, I want you guys to understand like how you can fetch data set across uh, from that web as well. Like this is like one of the data sets which we will be working on today. Since I have seen that most of the guys are here are have shown interest in cars. So yeah, we can actually use this cars to do our data analysis. Okay. So yeah, so see, first you go to the URL which I have copy pasted and copy the entire content of of this thing, right? Copy the entire content and then basically go back to here, say enter the plus sign, uh, uh, press the plus sign after you say text file. After saying text file, you copy paste it. Oh, not, yeah, you copy paste it here. Yeah, and for the guys who are using collab, what they can do is they can go to the folder in which they are working on. Okay, and you can just say wait, you can go to the file like which is basically here. Okay, okay, let me actually okay, what I will do, right, I will, instead of doing all of this, what I can do is I can just upload this file on the chat. On my computer. I have also uploaded the file on the chat. You can just directly download that file. Okay. And you should be able to see this empty cars.csv in your Jupyter lab. And if you guys are using Google Colab, okay, what you need to do is go to the Colab or what repository which you are using. Okay, I will, let's say I'm using this. Okay, so once you go, we are here. What you need to do is go to this, if you see this file section, okay, go to the file section. And once you like let it connect, like once it is connect, you will be able to get these options. You have to say upload to session storage. You say upload to session storage, and whatever file I have given you guys, okay, so this is the file which I have given you. You can just, you said okay, and then you should be able to see something like this. Okay, any doubts guys until now? This is major step. If you didn't get this, then you won't be able to execute any programs. Any any doubts? Were you guys able to create this file or download this file and get it like on the Google Jupyter Notebook or Colab? How about you guys? Imran bhai, okay. Siraj, cool. So now comes the interesting part. Okay. So here we will now use a library called as Pandas. Now, yeah, again, Pandas is a synonym of like the panda, but its actual usage is to basically do data analysis. Okay, so for using Pandas library, the first statement which you always should use is, since we are exporting something which is outside of Python, which isn't built in Python, you would import this library. For importing, if you remember, we will say import Pandas. This is how I am importing the library. Okay, and import Pandas as PD. Okay, import Pandas as PD. So PD is the short form for panda. So whenever we will be referring to pandas, we can just say PD. Okay. So this is the standard way of importing pandas library. So once you do this, you should be able to get no errors. And yeah, since you guys have installed from Anaconda lab, you shouldn't be facing any error. But if you face any error, that might be due to the pandas library not being installed in your Python context. So if you want to install, like suppose if you want to install something additional or something which isn't in your which is not present in your Python package library, like so what typically happens is like if suppose if you want to install a software, you go to the internet, right? You go to the internet, you download that package, you download that software, and then you install in your system, and then that basically reflects on your operating system, right? So that is what it typically happens. But for doing the same in Python ecosystem or Python environment, for downloading any package, there is a pip manager. There is a package manager for Python, which is like pip. We call it as pip. So you just basically have to say pip. Okay, and I mean this is a universal command. Okay, you can like just basically do it anywhere, like a hashtag pip install. Okay, whatever package you want. Suppose if there is one more package which I want to install, like that is Cbond, which will be working today. So Cbond, then what it will do, it will basically go to internet and it will see that okay, whether there is a package called as Cbond, where software basically like in terms like in layman terms software, or in Python terms and a Cbond package. Okay, it will automatically do it for you. You don't have to go and like download it and install it. You just have to say pip install Cbond, and you will basically get that whatever package, whatever dependency for the packages is required, it will basically install all of that. And it will also make sure that if it is already installed, in my case, it is already installed. So like for example, if suppose if I say uninstall, okay, there is install, there is uninstall as well. Uninstall pip cbon. Okay, I can't do this because I need to wait. So this command is supposed to be run on terminal. So you can go here and say other terminal, okay, where you will say pip uh, uninstall cbon. So it will also uninstall the cbon library. You just have to say press yes, and you see cbon is uninstalled. Now suppose if you want to again install, then you say pip install cbon. Okay, see, it is collecting the cbon. It is basically downloading all the files. Okay, and it will basically install it for you. Okay, see, here successfully installed cbon library, right? So this is how you can install or uninstall a new package in Python context. Okay, I will let me actually give this on the chat. Okay. For now, I will be commenting it out. Okay. So now once you have done this, import pandas as PD, now it's time to load this data frame. Like whenever you open Excel, like suppose if I open this, what do you get? You basically will get, like if you double click this, it will get opened in your Jupyter notebook. You will get like so let us first understand what exactly this data set is all about, right? Before even doing analysis, you would like to understand what exactly this data set is about, what are the different attributes with respect to this data set. So we can like go here and we can like empty cars data set download, where I have basically downloaded data set from. Like here you can like see like this is my MPG. Like there are, so basically in this data set there are different models of cars available: Mazda, Datsun, Hornet, Duster, Mercedes, Cadillac, Toyota, AMC, and Porsche, Ford, Ferrari, Maserati, Volvo. So yeah, all the boys might be getting very excited listening to all these names. But yeah, so basically, yeah. So but again, like with respect to these models, this is like miles per gallon. Basically, like how much miles do we get? Like basically the mileage, right? And then this column represents the mileage. This column represents the number of cylinders that specific uh, car has. This is the displacement. This is the horsepower. This is the drive shaft ratio. I don't know really what is this. It's the weight of the car. It is Q4, like what is the measure of acceleration. This is engine shape, like it is like V12, V8, or what exactly it is. This is transmission, auto or manual. This is gear, number of gears, and this is carburetors, right? So see, for example, let's suppose Mazda RX-4, what the mileage is 21 the cylinders is 6, the displacement is 160, the horsepower is 110, the draft is basically 3.9, the weight of the car is 2.6 tons, I suppose. Not tons, what is 2.6? Yeah, I don't know what the measure is. But yeah, but it is like 2.6 to and Qs, yeah, tons it would be. Yeah, tons make more sense. And then the measure of acceleration, and this is like the cylinder, like, and here you could see a number of different variables, right? Like here there is like here if you see this like model is basically here Mazda RX-4 is the model name, so it is a string parameter. Okay, it is a string. These all are numbers, right? Draft is a float value. Weight again is a float value. Acceleration like Qsec is also float value. Can you tell me what exactly is VS and AM? What is the data type of or engine type VS and this AM? Automatic or manual? What do you think the data type of this both? I mean, this both columns are. And then you also have gears and carburetor.
Binary, that is right. Like if zero, that means it's not automatic, and manual one means it is manual.
Exactly.
That's it. Oh,
Absolutely right on this. That here it is says that transmission or auto or manual. So zero basically means that it is a manual, and auto basically means it is like one, right? And similarly for VS, like whether it contains V engine or not, right? Like for example, if you go downside, the Volvo, or you could even say Porsche. Porsche will have this thing, right? Like it will have this V8 engine, right?
no, Porsche was a box wrench.
Oh, sorry.
Wrong information.
No, I'm not that into cars, so I'm so sorry. I'm more into bikes. Okay. So yeah, so gear and carburetors. Yeah, right. So this is like, okay, we have understood the uh like about the data, gist of data, what exactly this all there represents. Yeah. So now how do you load up using Pandas library? Okay. So remember, what do we call it? We call sheets, Excel sheet. Like whenever you open the Excel, it is called a sheet, right? Like in one sheet, you basically have one table, right? So that table, which is nothing but a combination of columns and rows, okay, is called as a data frame. Okay, it is called as a data frame in Pandas. Data frame is nothing again but the same exact thing. That is, it has rows and columns. So to load up in using Python, okay, using Pandas library is you say df, you create a variable. You can create any variable, but we generally prefer df. So df equal to, we use this Pandas library to say pd dot read csv. So this read CSV function, okay, is a function which is in the Pandas library, okay, to read the data from a empty cars.csv file. So I will just say read CSV. Okay, this there pd.read CSV, it is a function. And here I should give empty cars. Okay. So I have now read the entire this CSV file into a Python object. Okay, if you see the type of df, it is a data frame. It is a pandas data frame. Okay. So if you now, once you have loaded, if you just say df, you will get the entire basically the CSV file, the content of the file in this object, which is nothing but the rows and the columns. Can you guys try this out, whether it works or not? And let me know if you guys are facing any issues. This like major step. After doing, you have remember, if you do not do it, like suppose if I restart this kernel, if I directly execute it, it will basically complain that okay, PD is not defined because I have not ran pandas. I have not imported pandas as a library. First I have to run this, and then only I can run this.
So this type df function is that doing the purpose of calling the file, like loading up the file, and then df does the function of displaying it.
Yeah, you are right. Like it is the read CSV basically is the function which reads the file, and then you basically get all of the
Contents. Yeah.
contents into that object.
So type df is just loading it into CSV but not displaying it.
Yeah, it's a type is basically a function. If you remember, like type is basically just a function to understand what type of the variable it is.
Okay, okay, okay.
It
I
is
thought
not,
that's sort of loading it and then df
no,
is
no, no,
just
no. Even if you don't do this, like it is
right,
just
right.
to check.
Df does it. Right.
Yeah, just to check the what is the type of the function. So type of the variable.
So, okay, so we named the file df and then we executed the file. Now we could have named it anything else or it has to be df.
No, no. I mean, you have all the freedom. You can name
Okay,
it anything.
kuch bhi hai.
Yeah,
Chal.
it will still. So it is nothing but a reference. I mean, you can whatever variable name you can
Okay,
have it. But yeah, we typically, I mean, store it data as DF. As DF is the short form of data frame.
data file. Okay, data frame. Okay, thanks.
And Shadir, what is read CSV? This is inbuilt or we created it?
No, no. So this function is basically is coming from, so as I said, right, like here, when Python, one of the very good reasons people generally prefer Python, especially for data analysis, is because all the boilerplate code, like all the required code has already been implemented in some or the other library. Okay, like here we are using Pandas library, and this Pandas library has multiple functions, not just read CSV, but it can read from Excel file, it can read from different databases, it can read from JSON, it can read from HTML, it can read from even from your clipboard as well. So it has multiple options from the where you typically read the data from, but the most used one is only two of them. Read CSV, this is a CSV file. Okay, it is an alternative file, like we could say alternative to Excel file, where it's a universal format. CSV is basically called as comma separated files. Okay, so comma separated, why exactly it is comma separated? Because if you see, it is like a text file itself, but all of the data is separated by a comma. That is why the CSV file is called as, I mean, the full form of CSV is comma separated values. Okay. So by doing this, it is a universal file format. How you can store, let's say, like Excel is not, Excel can be supported in Microsoft Windows, right? But it won't be supported when you are using, like suppose by default Linux systems or like Linux systems or Linux servers or even Mac, right? You have to install Microsoft Windows, then only it will support. But CSV is supported almost on all of the operating systems. So typically we do all the data transfers and everything in .csv files. So yeah, so this .csv, like similarly you have read Excel and other functions, but the most top two function which has been used in for reading data from some file is read CSV and read Excel.
Shadir by getting error, like file not found.
Okay, what are you using for
Collab.
okay, you are using Collab. Okay, so in Collab, just make sure, okay, like just a minute. This thing is, yeah. Yeah, so
Yes.
here, right,
Mhm.
here, just make sure that you go here and say import pandas as PD. I hope you have already uploaded this file,
Yes.
right? And if you say df equal to pd dot read csv and say empty rs dot csv, are you able to see some screen something like this? Yeah, this is working fine. So what you need to do is like wherever your data is, okay, you can maybe share your screen. I will help you out. Wait a minute. I will stop the screen sharing. Yeah, you can share the screen, Faizan bhai. Oh, wait, I need to give permission. Yeah.
Visible? File is there.
Yeah. Yeah. So this error, right? What you do? you just go over there, go to content, go to content. Do you see the content? Yeah, you go to content. Yeah, go to click on content. Just click on content. Yeah,
Okay.
double click.
Uh-huh.
Okay, it is not going inside. Okay, no
No.
issues. Go to content, click on content and say upload. Yeah,
Yeah,
up.
first
Yeah.
one.
Can you check whether the under content, whether it is able, the data is there or not? Yeah, now can
Yeah,
you
no, it's
run the code again? Now can you say, okay, name df, yeah, yeah, no, it has run, it has run. Can you now run the below cell type of df? Okay, can you run, no, just run df. You don't need to run this entire thing. Just say df. Run it. Right? Okay.
Thank you.
Okay. Yeah, everything good until this, until here, guys. Okay, where did I? Okay. So now that we have the data in our data frame, I mean in the data frame variable, now we can do a lot of things. Okay. Now suppose in this data set, okay, if we want to only, let's say, read top 5 rows, okay, top 5 rows, then for reading top 5 rows, you call df dot head function. Head, as the word suggests, you will only get top 5 rows. So see, when you call df, you are getting the entire file, right? You are getting the entire 30 records. But if you want the top 5, then you say head. Okay, when you say head, you basically will get the top 5 rows. Okay, and if you say df dot tail, you will get the last 5 rows. And remember, the index here starts from 0, right? So there are 32 records. And so, yeah, df dot heads, df dot tail. Df dot head is basically will give you top 5 rows. Here, tail will give you bottom 5 rows. So these are nothing but your rows, and these are nothing but your columns, right? Just quickly execute these guys, okay? And let me know, like, as I go along, just let me know if you guys have any doubts. I will obviously wait, but since this is one line only, but let us like keep executing as we go along. Okay. So see, df dot head will give you top 5 rows, df dot tail will give you bottom 5 rows. And suppose if you want to know like what are the different columns inside this data frame, inside this table, you will say df dot columns. You can also press tab and it will automatically complete it for you. So see, df dot columns, then you are getting basically the list of columns which are available inside the data frame. Right? Any doubts until now? Okay. So yeah, so let's suppose now that you want to let's say you don't want top 5 rows, but you want top 10 rows. So you can call tf dot head and you can give inside the parameter. By default, it is top 5. But if you want to, let's say, if you want to like top 10 rows, then you give inside 10. then it will give you top 10 rows. If you say 2, it will give you top 2 rows. It will, if you say, let's say, top 8, and it will definitely give you top. Similar to like here also, like if you say tail, then df tail and then give 10, then you will like get the last 10 rows. Okay. Okay, I hope you guys are executing as I'm executing here. Okay. And I mean, we will just see there are lot of functions which you will see, like which makes data analysis very easy for you guys. Okay. So now let's suppose that you want to rename some column. Okay. Let's suppose if you want that, okay, this automatic AM is like very confusing. Okay. I want to rename this column to something which is more better. Then what you can say, df dot rename function is there. Okay, and inside this rename you need to give what exactly will you rename. Columns will be the here I will be renaming AM to here auto or manual. Okay, and close this. Then you will see this has been renamed to auto or manual. Previously it was AM. Okay, but still if you see, even though after doing this, if you still again call df, you will see that it hasn't changed to AM. Why? Because this operation isn't a in place operation. So what do we say as in place operation is because it just showed you the output, but it didn't update it itself. Okay, so for updating itself, you have two ways of doing it. Okay, either way, either I will, let me first create a copy of this original data set. OG data OGDF equal to df dot copy. So suppose if you suppose if you want to uh, like have it done, like even if you rename it multiple times, it will just show you the output, but it won't actually update its column name. If you want to do it, then what you can do, you can assign the updated value again to df variable. Okay, now if you do it, now if you see that that is AM, but if you do it again, like after updating it, then you will see that it has been updated. This is one thing. Okay, or else what you can do is, okay, like if I do df, you will see that this df is, again I have copied just AM. Okay, but if you want to do it in place, instead of doing this, there is one more method where it says in place. In place is nothing but a parameter inside the dot rename function, where you will say true. In place as in like whether you want to update the renaming of the column in place or not, as in like within whether it should update also or not. So if you do this, then you will see that it automatically gets updated. So you can either use any one of them. I preferably use this one because like in place equal to true, like that is the reason why it has been given to you guys. I can give this on the chat if you want. I have provided in the chat. Okay. All clear, guys, until here? This is the latest data frame which we have. Any doubts? Any doubts until now? Okay. Yeah. So, so let's suppose if you want to understand, okay, if you want to basically understand, okay, this is the data frame. By looking at it, you know, okay, this is a string object, this is a float, this is an integer, this is a binary and all that. But if you want to understand using like the data frame itself, then you call d types. Okay, and calling d types dot d types describe types of data in data frame. Okay, so as you can see here, the model PG and all that, like MPG is like if you see the data frame, let I will just call two or three rows. So see, as you can see, the model is here. String is called as an object. Okay, like string is basically called as an object. Like here, this is a string, and you won't see string object anywhere else. Rest everything is either a float or integer. Obviously, we can convert the data types. We will see it later. But for now, for understanding what are the data types for that specific data frame, you say df.dtypes. Dtypes is a function. And if you want to know what are the different functions available, you just say df dot and press tab, and you will get all of the available functions. Like there are so many functions available. Not all of them are obviously useful. Okay. So yeah, you guys can try this out and let us know if you have any doubts. Any doubts, guys? Shall we move ahead? Okay. So now what else, like when we say analysis, what else can we do? Right? What else exactly can we do? Like suppose given a list, suppose if this is the list of inventory of cars available in your showroom. Now you want to understand how many of your cars, okay, how many of your cars have let's say auto or manual, like how many auto cars you have and how many manual cars you have, right? So for doing that, like suppose if you want to understand the distribution, like how many number of auto cars I have and how many number of manual cars I have, okay, what you can do is you can first do, let's say, using condition. Okay, so now what you can do is say df. Now here we inside the square bracket we give the condition what it needs to be satisfied. Okay, we say auto manual df dot auto manual column is equal to 1. This is the condition for which wherever it returns true, it will give you those specific rows. So for example, when I say auto manual equal to 1, so these all cars are, I suppose, manual. Toyota Corolla, Porsche, and Ford, and if you do the exact same thing with 0, then these are all of the cars which are automatic, right? This is manual, and this is automatic, right? This is how you can use specific conditions. Like see if the length, if the number of records returned, okay, by the data frame, okay, by the data frame is less. Like whenever there is a condition which is satisfied by this condition which you have put, then only it will list that. Okay, this is called as filtering. Now similarly here, and you can do this with any of the columns. Okay, and one more thing which you want to understand is like how do you know how many number of columns and how many number of rows are present inside a data frame? So for that, that is nothing but it is associated with the shape. What is the shape of the data frame? Like what is the shape of the table? How many number of rows and how many number of row, how many number of columns. So you can call df dot shape. So the df dot shape will give you two things. Okay, the first thing is it will give you a tuple. Okay, the first is number of rows. In the tuple, you will have first number of rows, and second will have number of columns. So this is the total number of rows, 32 rows, and this is the total number of columns. Any doubt until now? Should we move ahead, guys? Okay. So yeah, this is how you can like use conditioning conditions inside like to get filtering out of the this thing, and this is the number of rows and columns. Okay. Now, what if you want to? What if you wanted to let's say that you want to uh, maybe convert, okay, or you want to only choose only one specific uh, columns, okay, only choose specific columns for your analysis, okay. Let's suppose that I want to only know what are the different models, okay. Then what you can do, like how do we call a dictionary? So nothing but like how we call a dictionary with the key. So this is your column is nothing but your key, and your values are nothing but this, like whatever it comes. So suppose if you want to access individual column, then you will say df, then you will give the key for which you need to get the data for. So df dot model, it will give you all of the data points available for the car. You will get all the car names. Okay, you basically will get all the car names, right? And also suppose if you want to like get let's say mpg, okay, then you do this, right? Like you basically will get all of the a number of this thing, I mean number of values available for the mpg column. Similarly, if you want to do it for vs column, and you will do this. And if you want to do for auto or manual, then you do this, right? You will get basically all of the values, right? So you can select any, and you can also select multiple columns as well at one point of time. Suppose if I want let's say model, I just want model, and here is a double list. Here I'm giving multiple keys inside. I'm giving double list. Okay. So nested list basically. So model, and then I want MPG mileage, and I want auto or manual. Auto or let's say manual, and I want gear. Okay, only 4 columns. Out of the 12 columns, I only want 4. Then you can also get only those columns as well. Like this is how to choose multiple columns at one point. But remember, even if you choose this, the original data frame will remain the same. It will remain whatever it is, the original one only. Only that here you are like here you are creating a temporary representation of what you want to see out of it. Okay. Yeah. I hope you guys are able to do this. I'm still copy pasting this on the chat. Okay. So similarly, like suppose now if you want to like have some like suppose you want to understand, by the way, you can also have call the single individual columns as .mpg as well. It will still give you the value, but let us prefer doing this way only to keep it standardized. Okay. So suppose for this column, this MPG, you wanted to calculate the mean of the column. Okay, we will definitely do some calculations, right? We calculate the mean, median, mode, and basically average, and we minimum, maximum, right? We calculate all the statistics from a specific column, right? We can do that over here as well. So suppose if I want to calculate the mean, then I'll say dot mean function, and you will get the mean. Okay, the mean of the MPG column. Okay. Similarly, if you want, let's suppose if you want to do, if you want to calculate the mode, okay, like the, let's say median. Okay. And similarly, if you want to calculate the mode of this column. Do you guys all remember what exactly is mean, median, mode? You can do this column for any column which has numerical data type in 64, right? Like mean, median, mode, or even let's say let's take a more specific let's say gear, or let's say HP, horsepower. What is the mean horsepower of your entire cars available? So mean is nothing but the average, right? Everybody, I hope, understands this. What is mean is nothing but average. Median is basically the value which comes in between, like 123, like which is the 50th percentile. So HP, right? Like this is the value which comes in between 123, so 32. So it should be around okay, at the 50th percentile, it should come somewhere in between. That is nothing but your median, right? HP. Okay, so this is, yeah, 50th percentile. And yeah, so, and also like the mode is basically like so what is the most repetitive numbers present inside your column. Okay, so this is mean, median, mode. We typically use mean a lot. Median and mode typically we don't use, but still. And suppose also if you want to calculate what is the minimum horsepower which your car has, okay, then you just say minimum. This is 52, and again also like maximum as well. Min max 52. The minimum number of horsepower which you have in your car inventory is 52, and the maximum horsepower which you have in your car inventory is 335. Now let's suppose you want to understand also, like, okay, which of the which car basically has this, like, okay, what is the, so what you can do is you can say, okay, what you can say, df dot HP dot minimum. Okay, and you can say df dot HP. So wherever, what you're trying to do is wherever your double equal to. So wherever your HP is matching with the minimum HP, you show that car. So as we have seen that Honda Civic is the one which has a very lesser horsepower of 52, and you can also see the cylinders and mileage and everything. Whereas if you see for the max, you can just copy this and do this for max, and you will see Maserati Bora is the model which has the highest horsepower of 335. Right, obviously the numbers vary, right? Like here the mileage which you get per gallon is 30 approx, whereas here you are only getting 15. It has 4 cylinders, it has 8 cylinders. The displacement is very less, where the displacement is very high. Horsepower is definitely high. Draft is still okay, I mean it is less. And the acceleration is also like pretty less, which is a good thing. It is both are like automatic only. It has 4 gearbox, 5 gearbox, 2 carburetors, 8 carburetors. So this explains a lot, right? So this is how you can do a lot of analysis, right? So for doing this, you can just say minimum and maximum, okay? And suppose if you don't want to do this, and if you want to directly do the sorting, if you directly want to do the sorting, then there are already different methods available. You can sort the entire data frame, okay? For example, I can just say df dot sort values the function, and you need to give the by, like what exactly do you need to sort by. I will sort it by HP, okay? And then there is a parameter called as ascending. If you say ascending to the true, you will get the entire data frame sorted by your HP column. Like how we do sorting, right? Like in Excel, this is nothing similar to that. This is exactly similar to that. Yeah, so if you see the first model which basically is on the list is Honda Civic with the less possible HP, and the last basically is Maserati Bora, which has 335 as a horsepower. And if you want, let's say this is for ascending, and if you want for descending, you just say it as false. You will get the first rows, like the first basically column. Sorry, first row is basically the one with the highest horsepower. And suppose you don't want the entire list. If you don't want the entire data frame, you can always call dot head after this. Okay. You can always, like this is the entire column. You can always call, let's say if you want top 3 rows only, say head. It will combine, like it will first operate, will first calculate this, and then will give you the top 3 rows. You can do the same exactly here as tail as well. And
Do you minimize these output thingies in Jupyter? Okay,
Jupyter only.
minimizing.
Like you have to click on this blue.
Okay, scroller. Okay, ठीक है समझा. Scroll, right click.
Shadir bhai, how to minimize output in Google Colab?
Collab, you just need to, like something like this comes up. You have to just do this. There's a cross button. You do this, and it will go away. Okay, so one thing which you guys have to note is that for any function call, we are using round brackets, like as we have seen the entire in our entire course, that wherever we are calling the function, it will be round brackets. And wherever you are dealing with data frame indexing or anything, it will always be like suppose calling out a variable name or anything, then it will be square brackets.
Shadir, why we put ascending is equal to false?
To get in descending order. When you say ascending equal to false, it will give you in descending order.
Okay.
Like here, like you are getting in descending order, right? Like here you are getting in descending order. Like if I say true, then you will get in ascending order. Like the first with the one first row will always have the lowest HP.
Like we had df dot columns, we don't have df dot rows. No,
We have different functions like for selecting columns, you are directly using
df dot column.
columns. Right? This is like, but the rows they have like columns are associated with their respective names. Like that, this is
Right.
the keyword of columns. But for rows, if you see the rows are having the index 0 to like the serial number is nothing but their index.
Right.
Okay. So now if you want to select, suppose if you want to select rows between
This model.
let's say 0 to 10, okay, then you have a function called as lock. Okay, df dot integer lock, I lock. Okay, so integer location. Okay, sorry, index location, not integer index location. And you inside this, you can first you need to give rows. Okay, like what all rows you need. Like suppose I am saying from 0 to like the same indexing technique was with what we have learned 0 to 10, 0 to 11 because I want the top 10 rows. Okay, and if I and then this is if you do this, then you will get the top 10 rows. So here df dot ilog, then rows, and then columns. So here I have given the columns only for the rows, right? But I can also give similarly, I can give numbers for this thing as well, for rows as well. Sorry, for columns as well. Like the columns like this, the model is nothing but 0, MPG is 1. Like how this is nothing but a list, right? So similarly,
Right.
give the range of this, I mean, columns as well. So I can say I only want the top on top, let's say 4 rows. So if I do this, then you will only get the top, like the top 10 rows and top 4 columns.
That becomes another way possibly, you know.
Yeah, I mean, but we always prefer to address columns using I mean using their names because that is very easy to understand what
Right.
columns are you using.
Working with, right.
Using this, you will get an index error because in this is index location. Okay, it only accepts
Right.
numbers. But there
Right.
is also one more column, one more function which is called as location, just location, which accepts both. Okay. If I do the exact same thing, like here you are getting an error, right? But if I do the exact same thing but with location, then you will get the output.
Right.
So this is the difference between these are two functions, index location and location. So index location only takes like here
Indexes.
you are giving rows and columns, it will only take indexes as integers, right? But if you want, let's say if you want to take it like from the
File.
string value, then you say better you use dot location.
Dot location. Okay. Thanks.
This is one example. And this is another example. I'm copy pasting it on the chat box.
Thanks.
Just keep on trying. Yeah, it works exactly like how range function works. 11th won't take the 11th index. It will go until 11 minus 1.
Shadir bhai, can you please once explain that file once again?
Index error. Any doubts? So until now, we have seen how we can select single columns and how we can select rows and like what are different things which we can do. Now there are some also other functions which are available, which you guys can utilize. Like let's give a context more to it. Like suppose if you want to understand, okay, if you want to understand what are the different types of, let's say, cylinders available in your cars. Okay, let's suppose that you want to understand what are the different cylinders available in your cars. Okay, so what you can do is df and then cylinder. Okay, and then there are multiple functions out of which one is unique. So it will give you what are the unique occur different cylinders which are available in your car. You can do the same exactly same thing for any other column. Let's suppose here. Okay. So when you say gear, then you have cars with 3 gears, 4 gears, and 5 gears as well. And if you want to understand which of the cars have 3 gears, because I never have heard of 3 gear cars, so what you can say is df. You can also use something like this as well. Gear equal to 3, and you will get all of the cars which have 3 gears. Oh, so there are so many cars. Mercedes, Valiant, Duster, and everything. Like these are the cars which has 3 gears. Similarly for 5, you can do this exact same thing using location as well. Using location function as well. Okay, which where you will see gear equal to 5. Okay. Right. So yeah, this is the unique function. And similarly, suppose if you want to count, okay, count the number of unique values present inside both of these, right? Like both have 3 different unique values, right? So there is something called as n unique function. What the hell is happening? Oh, this is not right, but yeah, n unique. So this cycle basically has three different types of unique. Like suppose if I do this for model, then should get me 32. Why? Because every other car has a unique name, right? That is why it is giving me 32. And suppose if you do this for auto or manual, then you will get 2. Why? Because it only has 2 values, 0 or 2, right? And suppose out of this, suppose if you want to understand, okay, I understood that, okay, I have, like, let's say for the gear, I have three different values, let's say 4, 3, and 5. Okay, like these are the 3 different values, but you also want to understand, okay, what are these 4 different, I mean, how many number of cars are available for these 3 different values? Like how many number of cars are with 4 gears, how many number of cars are with 3 gears, how many number of cars are with 5 gears? So instead of then saying, instead of using unique function or n unique function, okay, you have something called as value counts. Okay, what you need to do is gear dot value counts function, and it says that for gear 3 you have 15 cars, for gear 4 you have 12 cars, for gear 5 you have 5 cars. We can verify that, right? For if I ask for df.df gear, they're using this condition 5, you only get 5 cars. But if I do it for 4, you get how many? 12 cars. You can also like check the length of it. It is same, right? So this is how it works. Any doubts? So we have seen any unique function. Unique function will give the unique values present inside column, and n unique will give the count of this unique column, unique values. And value counts will give you not only the unique values but also the respective counts in a descending manner. Like the one which appears the most will come first, and as it will go on. Do let me know, guys, if you guys have any doubts. Alternatively, you guys can try out with different columns as well. Okay, I mean, you can just try out. Okay, remove after 11.
Not you, not you. That was for South, I guess. So, not you, Shadir. I answered South's question.
I mean, you still have that error, or is it resolved?
South asked that question. I replied to.
Okay, okay, okay.
So,
Okay. So you guys can try out with different other columns as well. Like let's suppose VS, you will get two unique values. And what else? You have MPG. MPG, you will get a lot of unique values because you have different mileages for other cars, right? So suppose, okay, now that you guys are doing it, suppose if I want to understand, yeah, we will do it. Like how to convert MPG to KMPL, how to convert, like we will do it. Thanks for suggesting it. But yeah, again, before that, before doing this, let me ask you the guys this question. If I wanted to understand which car is the one which has highest miles per gallon, how will you take that from this data? How will you know which? Can you guys extract the car name which has the highest miles per gallon? You guys have to tell me the car name which has the highest miles per gallon. Just don't go looking at the .csv file and tell me. You have to write the code for it. Yes, that's right. Absolutely right, Siraj. No, but this is but you have done it for horsepower. I want it for miles per gallon. Again, we don't have KMPL. Achha, you have changed to KMPL. Okay. No worries. Let me actually switch to KMPL formula. What is the formula? Okay, kilogram is equal to kilogram in inch. So basically kilometers per liter is miles per gallon into 0.425. Let's say 0.425. Okay. So I will tell you how we can transform the data. So yeah, so Siraj, you are right. For getting that, what you need to do is you have to say df dot sort values and say by mpg and ascending equal to false. Okay, and since you only need the first car name, you will say head of one. So you this is the car which has the highest miles per gallon, Toyota Corolla. Do you guys agree with this? I say Tata Nano, but yeah, Tata Nano is not in our car data set. But yeah, Toyota Corolla is the one which we have, which has the highest miles per gallon. Right? Okay. I hope everybody understood the how to do this. Now going ahead, like the one of the suggestion which Siraj has said is how to convert, like how we need to have one more column named as kilometer per liter. Okay, instead of having miles per gallon. So I have just researched the formula, like how to convert miles per gallon to kilometers per liter. So it says that the kilometers per liter is like miles per gallon multiplied by 0.24, 0.25, 425, right? So what I can do, I can create a new column, like just how we create a new variable, we can create a new column. I will say, I will name it KMPL equal to df of, let me first show how the data frame currently looks like. You know that there is no KMPL column, right? So, but I have MPG. So what I will do is I will say miles per gallon multiplied by 0.425. Okay, this is your, now if I again say DF, I will take only top, let's say 5. Okay, you will see that there is an additional column which has come into the picture, which is says KMPL, which is the which is basically we have created using the MPG column. Okay, so this is how this is how you can use the other columns to create new columns within the data frame. Use MPG column to create new KMPL column using miles to using formula. Any doubts? Similarly, you can create any column, like anything. Okay, so I will tell you something, and if someone is able to do this, then I would be feeling very proud and happy. Uh, okay, so let me see how you will. I mean, even if you guys suggest how it can be done, then I would be very happy. See the model name. Okay, now what I want you guys to do is I want you guys to create a new column called as brand. Okay, in which the car brand should be mentioned. How will you do it?
Split the cells, right? Split the first cell that has car maker's name pretty much.
Yeah, that's absolutely right. That's absolutely right. That's the answer which I was looking for. if you see the model name, you could see the pattern that after the first word is obviously the car brand itself: Mazda, Hornet, Valiant, Duster, Mercedes, Cadillac, Chrysler, Fiat, Honda, Toyota, and all this, right? Ford, Ferrari, Volvo. And suppose if you want to get the brand, okay. Now, if you guys remember about the lambda function, okay, like, okay, let me get we have something called as get brand, okay, and this would be, I will create a function called as car name, okay, and I will, for creating the brand, I will just say car name dot split, okay, and I will split it using space, okay, and after splitting in space, I will get the first element, because suppose if you have this Mazda RX-4, okay, and you say split, it will give you Mazda RX-4 and WAG as 3 different values. But I'm only interested on the first values. That is the reason I will only say 0. So I will get Mazda, right? So I will create a function which says get brand name, and I will just return brand. Okay. Now if I call this function with the same exact thing, okay. Okay. So you will definitely get Mazda. Now, if I do this for, suppose if I do this for, let's say, Ferrari Dino, then you will get Ferrari Dino, right? Now there are three different techniques available to create this new brand column. Okay, the first and the novice way is using list. What I will do is I will create a brand list, brand empty list. Okay, and I will do for loop for car name in df model. Okay, so df dot model is nothing but a series. You can consider as a list. Okay, so you can consider as a list. Like if I say car dot model, as you could see, you get a list of car names, all of the car names, right? What you do, you basically, for each of this car name available, you basically call the function get brand, okay, for that car name, and you append to that list. Now, once you have done it, you will just say brand list, and you will get all of the brands available for all of the cars. Okay, and what you will do, you will use this brand list to create the new column, which is nothing but brand. Now, if you see, now you will get the brand as well. This is the first technique, which is a lengthy technique, but people definitely use it. This is the first technique. Do you guys have any doubts regarding this? I will give you the brand name function, and I will also give you the list. Do let me know if you have any doubts on this. Okay, this was the first method where you are creating an empty list, and then using the for loop, you are getting the brand for each of the car name and then appending to that empty list. And then you append directly the brand list to create a new brand. Okay. One more method is, and also for deleting the row, or for removing this row, sorry, not row, column, what you can do is df dot drop. Okay, And here you have to provide the column. So I will remove column brand so as to make you guys understand all different ways. And you also have to provide access. Okay. I guess columns, we see, yeah. If you even say columns equal to 1, then it is good. And here also, even if you have removed it, but still it won't get updated because it will still be there because you are not saying in place. So I say in place equal to true. Now, if you do this, then you will see that the brand column has gone. The second way of doing this is what you can directly do instead of doing all of this. There is something called as a apply function. Okay. So what this apply function do? It applies the function for you. You don't have to create the for loop or create the empty list or anything. What you can just say df, and you need to like whatever your function is getting the input as. Like here I'm getting the car name, which is nothing but the model, right? So I will say model, okay, and then apply. Okay, what function will I need to apply? I will say get brand. Okay, so if you see after dropping this column, let me also copy paste this. For dropping, after dropping the column, if you see there is no brand column, right? But if I do this, like if I say df model dot apply get brand. So what I'm doing is for each of the values present inside your model name, like which is nothing but your car name, just apply this function and get and append the output to the new brand column. So if I do this, if I again do head, you will see that there is a new brand which automatically comes into picture. You don't need to do this here. This is second type using apply function.
So this one did not split it, right, to get the brand name. Is it pulling it up from some sort of a repository?
Logic which we have written for splitting it is in the get brand function itself.
Okay, so get brand function it's pulling. Okay, sorry, I thought like that's a command.
No. The get brand function, whatever function you want to do. Like suppose if I want to, let's say if I want to get the length of the characters for the band. Okay, so I will say get length, or even let's say, okay, let's do get some meaningful information. Let's suppose yeah, let's suppose we want to classify, okay, we want to classify whether a car is economic or sports car. Okay, economic car or sports car. Like suppose if we say the mpg value, if it is let's say less than 12. Okay, if it is less than 12, then it is a sports car. Like less than 12 miles per gallon, it is sports car. Otherwise, let's say 15, less than 15 is a sports car, and more than 15 is an economic car. So let's suppose I will say economic or sports car. I will define this. And here I will be taking mpg. So here what I will do, if mpg is less than 15, then return economic. No, sorry, sports. Else return what? Economy. Right? I have defined this function here. The logic here is coming from here. Okay. Now, if I want to create a new column based on using the same exact thing, then I can say df type of car. Okay. Let me also type of car. Okay. I will say df. Now, what does this function take as an input? What does this function take as an input?
mpg.
mpg, right? So you will use mpg value, mpg dot apply this function name. And now if you say df dot head. Sorry. You will see that the type of car has come. Now using this type of car, you can do a lot of other stuff. Like suppose example, I can like count how many types of car we have. So if I say value counts, so I have only 5 types of sports car and 27 types of economy cars. Please try this out, guys, once. Any doubts, guys? Let me know if you guys are done, okay?
When you do this, right, if you run df.head, it returns in the format. But if you run a df, it messes it up big time. The format. It gives the information, but the format goes crazy. What is that?
I mean, like if you say df, then it goes
Yeah.
like it basically has all the data, is it?
No. Okay. Let me try.
Hmm.
Now it has, when I ran it initially.
Sometime it happens, yeah.
Okay. Okay. ठीक है, चलो.
Okay. Yes, let me share the screen once again.
Have you got one question?
Yeah.
Can you scroll up?
Hmm.
So now we are getting the extra raw, that is type of car. So where we have added this?
Here we have added, right? Like here we have added. So by doing this, you get an extra column already. You basically, like if you just run this separately, okay, you will get a list. You already get a list. Okay, so you are just using the list and appending it to a new column, which is like type of car. In place, how to make, I didn't understand, Siraj. Like if you do you want like true or false instead of sports or economy?
No, I want to like there is one function no in place is equal to true, which
No, so
will
that
not.
here you don't need to, here you don't need to give like in place only, like it is, since you are appending here, I mean here that is in place is not supported, I mean not supported by every function. Here since you are like creating a new column itself, you can just use this, like there is no need of doing in place.
It will save it directly.
Yeah, it will save it directly. Like see, if you see like previously it wasn't having it, and it is now having this type of kind.
Okay.
Sadhbhai, line number 117. Here we have created a new column, type of car.
Hmm.
But why we have defined SPG here?
Why I have defined as?
MPG.
Yeah, so because this economic or sports car relies on MPG value, right? This MPG.
Okay, so this column should be depend on this MPG.
Yes, yes. Okay.
And what is this apply is doing to this economy or sports car? What is doing apply?
Inside it is doing this.
Okay, we have run the for loop separately, and we are applying on this one directly.
Yeah, so instead of like having this written entire like 3, 4, 5 lines of code, you are doing everything in one line of code.
So MPG is acting as an index and apply is acting as just creating the list, basically, an
Yeah.
additional column in the list.
Yeah.
Okay.
Okay, so yeah, this is, and the last method, if you guys remember the lambda function which we talked about, okay, in the lambda function you don't even need to like create the function, like you can directly use lambda functions to do something. For example, let's suppose let's say if you want to what condition we can have. Let's suppose I want to cylinder. Okay, so suppose if I want to let's say if the car has less than 4 cylinders, or less than, let's say, 4 cylinders, then we can say high cylinder, or or let's say less cylinders, something like that. So for doing that, we can say cylinder type. Okay. Yeah, we can. ठीक है. So what we can do is df dot cylinder will, and then I'll say apply. Here comes the magic lambda function, lambda x. Okay. What I will do is I will say that like if x, which is nothing but your cylinder, if x is greater than 4, then my value would be high. Okay. Else it would be low. Okay. If I do this, now if I say df dot head, you will see that there is cylinder type as high or low, new value which has been created. Wherever the cylinder value is, let's say 6, it is says high, and wherever it is like it is saying 4, it is saying low. Right. So here the only difference between this and this is that you basically have used your lambda function, that is you explicitly didn't created one more additional function, rather you used everything in one line of code. You didn't even need to create a lambda function itself. So multiple ways, I mean, you can do however you are comfortable with, at least for getting started. This is only useful when you are dealing with billions and trillions of data, like where you need to worry about memory and space and time and everything. But otherwise, we generally use this one only, apply function itself. Okay. Any doubts until now? Okay, so we have seen how to filter records. We have seen how to apply functions. We have seen obviously other stuff as well. And so just a minute. Yeah, and we have seen a lot of things. And yeah, so and there are other things as well, like suppose if you want to let's suppose if you want to calculate the mean, median, mode, min, max of any specific column altogether, then what you can say is you can use a describe function. Let's say mpg, and you say describe. Okay. Oh, sorry. Then you will get the count, you will get the mean, you will get standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile max of the specific column. Okay. Now, suppose if you want to now, we have seen df.d types, right? Like we have seen that the model is a string object and mpg is of float. This is fine, but this auto manual should be of Boolean, right? It should be of Boolean, like it is in 64. But to keep it, like you can convert between formats as well. Okay. So yeah, so basically yeah, so what you, for converting a specific column into a different data format, what you need to do is you need to select that auto or manual, and you will say df again auto manual. there is a function called as type. Since you are converting as type, and here you will give the type of the variable which you want it to be. Here I'm saying it should be Boolean. Okay. Now, once you have done this, if you again check for D types, you will see that it has been converted to bool, which is nothing but Boolean. Okay. Similarly, you can do, like, for example, if you want to convert this model object, it is, if you even if you convert to string, it will still remain the string itself. Like if I say it as model, or let's say brand as brand as str. So if you say df dot d types again, you will get that the brand is unchanged because it is already of the string object. This is how you can convert between data types. Like suppose if you see the mileage, like the mileage is in, like, let's say mpg, right? You want it to be in from integer format, then what you can do is say mpg equal to df of mpg dot as type int. And now when you say df dot head, see the difference. This was 21.0, now it is 21. This was 21.8, 22.8, it is now 22 only. So all the decimals have been gone. Any doubts, guys? Any doubts until now?
My brand is not changing to string. df.data is, should I share my screen from df str? Yeah, that's what.
Oh, I'm so sorry. I was in mute. Uh, yeah. But it's okay. I hope you guys understood, right? Here I'm using the and condition like to combine multiple conditions. Okay. To basically combine, like here you have one condition and the second condition, and like here if both of the conditions are true, then only you will get the output. Similarly, you can do it for like you can do it for this thing, like suppose or condition, like suppose if you want to get for let's say if the brand is, let's say, Mazda, okay, or the brand is, let's say, Toyota, any of the brand will work. See, here you are getting for both of the brands, Mazda and Toyota. This is like or condition, this is and condition. I hope you guys remember what is the and condition and what is the or condition and how it works. Okay. Any doubts?
Abdul, can you tell again about the LOC, this condition?
See this here, LOC is nothing but a function. Okay, it is not a condition. Like you can even replace it. You can even do this. It will still work. LOC is nothing but for getting the location. It is just a you could say location is a function in which if you provide the index, it gives you the value. You can even do the indexing filtering by just having this also. Remember, guys, the round bracket is important, otherwise you won't get the output. Yeah, like going ahead, like suppose if you want to make the brand lower, like suppose if you want to make all of the characters inside the brand condition lower, and you say df brand dot apply x dot x lower. This is one way of doing it. Now if you say df brand, then you will have everything as lower, right? Like previously uh it was in camel case, now it is lower. Suppose you want to again do it, then there is one more way of doing it is say brand. If you don't want to use the apply function, there is a built-in functions available, like how we do it for string, like say brand, and you call dot str dot capitalize. And if you call it now again, if you see it, it will have returned to the same what it was before. So you can either use the string functions or by directly calling the creating the lambda function or creating your own functions, whatever you want to do. But if but there are also direct functions available by using .str. Okay, by using .str, and it will automatically give you all of the functions which are available for the string, like dot lower, dot upper, dot capitalize, dot cam, dot is digit, is upper. All the functions which we have seen is also available directly. It will automatically get applied to each and every value, and it will get written to the output.
I scroll up a bit where we did that other brand thingy, the equal to
Yeah,
above.
or condition.
Yeah, the or condition, sorry.
Shadbhai, what this function will do? str.capitalize.
So it is a shortcut method of, if suppose if you want to apply some string functions and you don't want to write for loops, or you don't want to write apply or use apply or lambda function, everything, like you just want to do single things, like for example, uh, like capitalize or lower or upper or anything like that, then you can, there's a shortcut where you say .str and dot whatever function you want. Okay. So yeah, so we have seen a lot of functions which is applicable for while using pandas. If you remember, all this is uh, more than enough. And suppose, and on one more thing is, suppose if you want to let's say combine any two different, work on or two different variables, or so two different columns, and you can also do that as well. Suppose if I want to add the gear and the gear and the carburetors and add into one column, then I can just say gear uh, gear and let's say carb. Okay, how we typically do for the number side, I'll just say gear plus carb. Now, if you see df.head, you will see that gear and car, there is no such column. And 4 plus 4 would be 8, 4 plus 1 will be 5, right? If I do this and again like call dot head function, you will see that it is the addition, like both of the 4 plus 4 is 8, 4 plus 1 is 5, 3 plus 1 is 4. Like similarly, like it basically, this formula applies for each and every value. You can similarly do anything you want. Okay. So one last thing about Pandas library, I mean, is about yeah, one of the most important things which you will come across, that what you will do. Okay, what will you do? Suppose if for some of the let's say that, yeah, two things. Okay, update, how to update a specific like let's suppose that you have updated, I mean, Mazda RX 4, the MPG value for Mazda RX 4, you found that the data is not right. You need to update the value which is present inside MPG for Mazda RX 4. Okay. So what will you do? You can, like, you need to update, right? First of all, you need to filter for that specific car row, Mazda RX 4. Okay, you can do it two ways. The first I will let you know. Then you have got this, right? Now you need to update, right? You need to update the value, this MPG value, which is coming as 21 to, let's say, 26. Okay, so this is how you update using lock condition. Okay, like this is how you update using lock update using lock indexing. So if you see here, Mazda is 21, MPG value is 21. If I do this, right? If I now again say dot head, you will see that the MPG value has been updated to 26. Similarly, you can do the exact same thing using iLock. Remember, iLock only take numbers, right? So the first it will take a row. So row it will be 0. And also the I need to take MPG is coming at index 1. So see, it is getting 26. So this is using iLock. So this is like update using iLock, which is integer location. Like you need to give the row and the column at which you need to update, right? So yeah, I will update to back into 21. So now if I again like say df.head, we'll see that again it has been updated to from 26 to 21. This is the difference between iLock and location. And you can like also update for multiple brands or for multiple rows. Okay. So how will this happen is I will use the same exact thing. This was just for one row, right? And suppose if you want to update for, let's say, instead of saying type of car is, let's say, economy, I want to update it using basic. I don't want to say it as economy. I want to update it using basic. So what I will do is df of location. Okay. I will write the condition here that wherever df dot type of car is equal to economy, right? And I need to update which column? Type of car column. This is I'm using, since I'm using indexing, like giving the key values of the column. That is why I'm using lock condition, and I will update with basic. Now if I say head, you will see that wherever there was economy, it was updated to basic. Now you can revert this back with the integer location column by using iLock, and location of economy, the type of car. I can use Python to directly get me the df dot columns. Okay, dot index economy. I need to convert these columns to list, then only I can use index. Okay, economy. Oh, sorry, this would be type of car, right? Yes, this will work without even this type of. Need to convert to list. Yeah. So 14 is the column index. So I need to give the row. Sorry, I need to give like all of the rows. Okay, I need to give like the condition that df of 14, df of iLock of all the rows, and 14th column is equal to economy. I need the 14th column. Okay, location. Acha, it doesn't have. Okay, so this basically doesn't even have that option of updating. So you can just plainly depend on. I mean, typically we use this only. So you can plainly depend on location to update on multiple columns. Yeah. I will send this one more example. Okay. And last but not the least, the one of the major things is okay. So we have this df, right? Now let's suppose due to some error, okay, due to any error, okay, what has happened is that let's suppose wherever like you have let's say that you have null values, okay, null values for, when I say null values, the your data collector or whoever is collecting the data, okay, has unfortunately missed putting 4 as a cylinder value for all of the cars. Okay, so first I will update this just to create this null value. Okay, df dot cylinder equal to 4 and the cylinder column. So you're getting this. So I will update this to none. Okay. So now if you see head, you will see there is a nan value. Nan is nothing but none. So it basically represents that, okay, I mean, all these values do not, all these cells for that specific car, we don't have the cylinder value for it. Okay, we don't have the cylinder value for it. Okay, so now let's suppose now you come to know that, okay, I need to update for this wherever there is none. You know that, okay, this could be, I mean, the potential value that can be updated can be 4, or it can be 6, or it can be whatever, but let's suppose 4, since we already know it. So for updating that, there is a uh, function available for it, okay, called as fill na. Okay, so dot fill is taking so much time. Yeah, fill na function in which you tell that what value wherever there is null value. Okay, like if I want to check where if you have null values or not, you can say dot is null, okay, and dot sum. So it says that here model doesn't contain null value. This is check missing values. Okay, so this is how you can check missing values. So here it says, since we have like whatever we have make the none value for a cylinder, here it says only for the cylinder variable there are 11 missing values. So to fill these missing values, you have fill na function. Fill missing values. You can fill it using mean, you can fill it using anything, okay, but you can also like give the default value fill na, okay, and you would see that now this fill na has basically given wherever there was null. Previously there was null wherever there was null. Okay, you can also check, okay, df dot is null function, and it will give you all of the, wait, df dot cylinder is null. So these are all of the data where there is a null function, the cylinder value is null. Okay, to get okay. So check missing values, and now after filling it up, okay, and you have to do in place equal to true. Okay, now if you run this again, you will find that all the missing values have been filled. Okay, and if you like check for this as well, you will get empty records. Why? Because all the null values have been filled. See, wherever there was null, it has been filled with 4. Right? But previously the cylinder was in integer format, right? Now, but after filling it up, it has come to float. So what you can do, you can convert the cylinder to back to again integer by using as type function, as type int. Now if you see df dot head, it has came down to 4. You can use the mean to, like suppose if you don't know which value to use for filling up the missing values, you can use the mean of that column. If it is a numerical column, you can use the mean or the median, because mean or the median is the most probable value which will occur mostly, right? Or if you're not, if it is a string column, and it is a column which is occurring multiple times, then you can also use mode as well, but that is like more advanced analysis. But yeah, this is how you can do it. Any doubts until now?
शायद भाई मेरा ये ना 4 वाला 0 हुआ नहीं अभी, वो
Or
खाली ट्रू फॉल्स करके बता दिया उसने मेरे को, बट इट डिड नॉट चेंज इट.
this one?
Above I guess, wherein you, okay, let me try.
Shadow
Issue,
three.
yeah. Okay, so yeah, right, we did this none,
So you
and
don't have to use double equal to, you just have to use single equal.
okay,
No, no, not over there, that is fine. You are, since there you are checking the condition.
okay, here we have to make,
Yeah.
okay, so double equal to is more logical, is it?
Yeah,
And
yeah.
this is more object thing. Okay. DF4 0 0 0
Nan, you can see.
9 ठीक है, right समझो.
Okay, so yeah, this is how you can like fill in the missing values. You can also, by the way, you can like suppose if you are not confident that like suppose after like showing this up, okay, and if you're not confident that what is should be the value, and you think that those data points shouldn't be present in your data set itself, you can, instead of saying fill NA, you can just say drop NA, and you just have to say in place true. Okay, and now if you see, you won't find the records wherever there was null values, even if you see is null dot sum, if you check, there won't be null values, but the number of records would have decreased by 11. 32 minus 11 is 21, right? So we have dropped all of the values wherever there was none value for cylinder. We have deleted, removed that from our data set. Although it isn't the best practice, but yeah, whenever you want to drop it, you can do it using drop function of values. Drop rows where null values are found. Right? Okay. Let me
शायद भाई इसमें कंट्रोल जी फंक्शन है क्या? अभी डिलीट कर दिया तो हाउ डू वी गेट इट?
No, no, no.
नहीं
That is why you should always have to be careful whenever deleting data.
I updated so much and now.
Okay, so yeah. So moving forward, just let me know, guys, if you are able to complete it doing this. Okay, so yeah, so this was like we directly did, I mean, all these operations, right? We read the data from the data frame, and we did a lot of analysis. Now obviously, like, we have done a lot of changes. Like, this was the initial data set, and now if you see the current data set which we have, right? Uh, it has multiple columns and less number of records, right? Type of car, and it has multiple new columns: brand, type of car, cylinder type, gear, and whatnot. So you can, what we can do, suppose if you want to store this data set back to the operating system so that you can share this data set to anyone else. So instead of saying read CSV, like how we did read CSV, you have to call function toCSV. Okay, so toCSV, you can give it a name, let's say empty cars updated dot CSV, give the extension, and also give one function, give one parameter called as false, empty index equal to false. So I will tell you what exactly the difference is. Okay, now that if you see toCSV, this will get updated. You will see the file getting stored here. Okay, you will see that there are less number of values, and also you will get the, as compared to the original data frame, you will get all of the or additional like all the variables covered here, car, KMPL, brand, type of car, cylinder type, and everything, right? But you will see an additional field as well here, which is nothing but the index field itself. So we don't need this index field, right? So that is why I will say here as index equal to false. So by doing this, if I load it up again, you won't see that. You won't get the index here. So yeah, this is how you can again save the CSV file to back to the file system. Okay. Now coming on to how to create pandas data frame directly. Okay. So you can create the pandas data frame directly without loading it up from anywhere by calling the pd.dataframe function. Okay, for example, pd.dataframe function. Okay, and remember, in the data frame function, you are give the all the list elements which you will give should be of uniform length. That is, it should match. Okay, like 12, like here I'm giving 4 records. So here you are providing a dictionary. So remember, dictionary, like this, age is your column, gender is your column, salary is your column, and this is nothing but your values, nothing but your rows. So like for example, the first row will be 12 male, 3 4. We used this earlier for school. Yeah, exactly, like the same exact thing. School students related problem. So you can use that as well. If I do this now, if I say df, then you will see that okay, that this has been done. Age, gender, and salary, and everything has been come up in the table format, rows and columns, right? And you can do all of the operation whatever was mentioned. So one operation which I will show you is, like, let's suppose if I have one more data frame. Okay, let's suppose you load it up somewhere or anything. Let's say this is 24, 34. So senior citizens, let's say. He, 24 is not senior citizen. 6. Let's keep this. Salary is, let's say, salary is none here. This guy earns approximately 10,000. He earns approximately 90,000, and also doesn't have none. So now suppose there is df and there is also df1. Okay. Now suppose if you want to combine these both of these data frames into one, then there is now you can use concat function from pandas pd.concat, in which you have to provide the list of data frames which you need to combine. Okay, and yeah, which if you give, then you will see that both of the data frames have been combined. Also, you will see the indexes have been retained. 0, 1, 2, 3, 0, 1, 2, 3. If you don't want indexes to be retained, that is, if you want the indexes to be done again, then you will say reset index function, and you will get the, and also you will say drop. So see, now it is coming from 0 to 1 to 7, and everything has been combined. Also the NAND values. Okay, so this is how you can combine both of these data frames. Okay, so this is df1. I have So if you want to combine, like let's say combined df equal to this. Combine df, you are getting everything as right. Remember, like here we need to give the list of data frames. If suppose if there is one more data frame, let's say df3. Let's say I create one more data frame with the same exact just to showcase df2. Okay, I can also have df2 also here. Now you will see that it has been again, like it has gone more record number of records. And the reset index is basically to make sure that there is no additional index column which comes here, and drop equal to 2 as in drop their index column. Okay, now yeah, now suppose if you want to fill this null values, na values. Okay, like since like okay, they are not earning, you can like say it as 0, right? 0 is a proper figure for saying they do not earn anything. So what you can do, combine df, okay, dot fill na with 0 and in place equal to true. Okay, let me keep this here. Sorry. And let me keep this here. And now again, if I say, and you will see that 0 has come in place of nan. Okay, you can also like instead of, let's say if you don't want to fill it up with na, then what you can do, you can fill it up with the mean value of the salary column dot mean. So now see, although this doesn't look good, right? The mean value is for wherever there is null value, it has been replaced with mean. Okay, or mean, or you can also replace it with min as well. Like let's say min makes more sense, right? Like let's say min. So now wherever there is null, it has been replaced with minimum. So you can like similarly replace null values with minimum salary value. This is how you can combine different data frames. Any doubts?
Shadir bhai, can you please scroll up a little bit where we updated the name of the file, that is empty cars have been updated. Why I'm getting the error?
What exactly are we getting?
Uh, Let me just copy paste it and check myself.
Yeah. I hope you guys don't mind having 3 hours lecture from now on, because yeah, since we are like learning all the applications of Python, it might take some time for you guys to, although we are moving rapidly fast, but still like to cover all of the syntaxes and all the functionalities. I want you guys to learn all of the things which is there in that specific library so that it is very useful for you guys. Faizan bhai, you can share your screen if you want. Sure, done. Okay. Yeah, I have copy pasted it, Siraj. And by the way, it is not .txt, it should be .csv, because you are storing it in .csv format. Yeah, because you stored it in dot text, right? Like if you see dot to CSV, you stored it in dot format. So you should be storing it like the how I have done it. Uh,
And Shadir bhai, if all are okay, then can we start from 7:30 by tomorrow?
the only thing which is concerning is that
Yeah, Maghrib timing now, so it's
that's
decreased
okay.
now. Yeah.
Otherwise, I would have. I mean, if everybody is comfortable, I don't know. I mean, everybody is comfortable, then we can even start at even early in the morning as well. To if you guys want to not have late night calls or I mean late night this thing. Like even if you guys want after Fajr as well. No, obviously after Fajr will be I guess a little difficult, but let's say morning 8 or 9, 9 to 11, 12 or something. I mean we can have that, but that is obviously subject to everyone's availability. So you guys can internally discuss within the group, I mean our bytecode group, and you guys can let me know. I mean I'm comfortable as long as you guys are comfortable. Okay, so yeah, so we have seen how we have combined the DF and how we can like impute the missing value with minimum mean or whatever you want. And yeah, so similarly, the one thing which is remaining is okay, the only thing which is remaining for today is yeah, so yeah, so how do we basically have join operations? Okay. When I say join operation, it basically I will give you some example. Okay. Stop. So suppose if I have df1 as with columns a, b, and c. Okay, with the range function, I am saying 1 to 6, and then like you can consider this as well as range starting from let's say 100 to 106, 1 a, all arrays must be of the same length. Oh yeah, 101. Okay, this is your df1. Okay, and you have df2 which has a column, and you have like product which is like medium classic. So there can be multiple instances, right, where your data frame is not just it is not present in one CSV file or one Excel file. It can be on multiple sheets. It can be multiple files. Now, how will you join both of the data frames in such a manner that here I want to combine I want to get something like A, B, C, and product. Okay, since like and how will I combine it using the anchor or using the common column which is among both within the both data set, which is column A. Column A is common between df1 and df2, right? So for to combining this, what you can do, you can call on the merge. Okay, merge, or you can let's say when join is the same. So this is your left merge. Okay, there are different 4 types of merge operation. Okay, so since there are 2 tables, there are 4 different possible options. The first possible option is you combine everything. Okay, you like the first option is like to combine the left. Okay, so I'm saying df1 dot merge df2 on the common column. The on parameter will get the a, and how you want to combine is left. So if I now, if I print the df left, you will see that it is a combination of, okay, it is a combination of a df1 and df2, but okay, df1 has came entirely, okay, like the left column, this is the left column, left data frame, this is the right data frame. And when you say df left, all of the data from the right left table have come, and only the data which has a common parameter, which is like which has same value as a on both of the tables, has only come on the right side. See, product, it has only four, right? It has four rows and it has 1, 3, 4, 6 as the values. Now, can you tell me what are the values which are common in a df1a, df2a? Like, what is the common?
134.
1345
Yeah,
134 only, I think.
134.
Yeah, one. See, that is why the left column, okay, it has only values for 1 and 3 and 4. There are no values for 2, since df2 doesn't have 2 here in a. df2 doesn't have 5 in a, that is why it has come nothing. So whenever you want the left data frame, left table to be as it is, and you want just to combine the right side, have the common data from the right table, then you will merge on left, okay. And this is, and you, this is similarly for right as well, okay. When you say df right, you can name it anything, by the way, but this on how condition it should be right. Now here it will give the priority to the right table. The right table has df2 has 4 rows, right? So that is why it has 4 rows, but it didn't, it only gave me all of the rows where left column is equal. See, there is no in the left column, which is df1, is there anything which is which is 6 here? A column has 6 value? No, right? It doesn't have. That is why here, even though df right has 6, okay, but here B is nan, C is nan, because the right table doesn't have, and but yeah, product name, because it is present in the right table, okay. And suppose if you want to combine both of them in such a manner that wherever it combines, then only you give it, like the like inner join, right? This is called as left join, this is called as right join. And if you want the inner join, then you call it as inner, and you will see only where a is common between both of the tables, okay, only where a is common both of the tables, then there only you will get the output. That is why here there is no nan value here. There is no nan value here. So there is nan value here in the right and the left, but there is no nan value, because only where a condition matches, then only a value matches for both of the tables, then only you get it. Okay. And the last one is nothing but you have something called as outer. Outer is basically that you get everything irrespective of whether it matches or not. You just get everything. You get everything. Wherever it matches, it gives you the value for that specific table, and wherever it doesn't match, it gives you none. Okay, wait. Yeah, this. I am copy pasting all the code on the chat box. Okay, and just to show you different joins in You can SQL, you can SQL also, it follows the same exact thing only. Okay, so see, yeah. So as you see, in the inner join, only like if you guys have studied sets, if you remember set, okay, in the, yeah, this basically gives a good intention. Uh, it in the left join, like when we say left, you basically will get all of the records from the left table and only the common records from the right table. Whereas the right join, right, the right join, you get all of the records from the right table and only get the common elements from the left table. In the inner join, you only get what is common in between both of the table. Okay, and in the full join, that is like which is also called as outer join, you get everything. Any doubts on this? I mean, typically we use left join only for joining the table because we want to keep one data set as constant and the other one, wherever there is common item, we will merge it. Otherwise, we will ignore it. So we typically use left only. But yeah, but the other joins are also possible. So yeah, that's it for today. We have learned a lot of things for with respect to Pandas library, which is extensively used by all of the data analysts and data scientists in the entire world, using Python for doing data analysis, for going through for doing data manipulation, for doing all the analysis. You can automate a lot of stuff by doing this. So yeah, any doubts, guys? Like this is like one of the finest example how Python has basically used in data analysis and data engineering and lot other stuff. So if you know this and if you know SQL and also you know Python, then you can make up a good case for an entry-level data analyst job. Obviously, you have to practice a lot, but it's worth it. I was trying to cover data visualization today as well, but I don't think so we would be able to cover it. So I will be covering it tomorrow. And also along with that, we will also see how Python is used for doing a lot of variety of automation stuff. Any doubts, guys? If not, then we can wrap up the session. And thank you. Thanks a lot for joining in. And yeah, we will see you guys then tomorrow. We'll see you guys tomorrow. Take care. Happy learning. Bye.